Is that just me?
You're muted.
I just
Well,
got
listen, you can continue. We'll just admit people as they come in.
All right.
Transmission, I believe you finished. Oh,
I
I'm not in the share mode. Sorry about that.
Yeah, I'll just say.
Okay.
What happened?
I don't know. Meeting shut down on its own. All right. Do you see your substation back up there, Willison?
Yes. I think I was at transmission lines, but that's fine.
Will do. Stand by.
You just finished it.
Did I finish it? All right.
Okay.
Yeah. Used to transfer the extremely high voltage. All right. This to the distribution or transmission substations.
Okay.
Distribution substation used to convert and redirect the transmission voltage into a distribution voltage for residential areas and use.
All right.
Then a step-down transformer converts the high transmission voltage into distribution voltage by converting the electricity into a lower voltage.
Yeah.
That's safe for a residential area.
Kind of tough on this one, but it is a step-down transformer. The bushing size on this side is almost the same as the bushing size on this side, but it's about half. So
It's not that green, the one with the green line? No, that's the ground, isn't it?
the green line is actually a light. These are light. So you have the transmission input voltage on my mouse.
Yes.
Then you have the output voltage on my mouse. Then right after that, they put a lighting arrestor to help protect the transformer. So that's a lighting arrestor right there.
Ah, okay,
And
okay.
that's the ground that goes down to ground. Good picture.
Bus bar distributes and redirects electricity inside the substation with great ease and efficiency. Kind of the same as a switchyard.
Yep, same thing. A good picture too.
Then we got a distribution breaker. Can be used to de-energize a circuit if maintenance is needed to be performed. Protects the circuit by opening the circuit through a switch if a fault occurs. Faults include overloads, faults to ground, and transformer faults.
Correct.
Or some of the faults. Voltage regulators maintain the distribution voltage at the acceptable range of operation. So whatever you want is going to be, at least in the America, is going to be plus or minus 5% the desired value.
Mm-hmm.
And provides a consistent voltage value on the output side.
Yeah. While we're sitting on this picture right here, I don't know how old this picture is, but this is not allowed anymore. You'll notice that the regulators are mounted on a pad at ground level. I would say these are probably 6 to 8 feet tall up to here. They now require more height in the air, so you won't see them mounted on a slab anymore that you see like that. And I can tell you one thing, it's a good safety thing. We'll talk about this when we go into substations. A lot of this equipment's awfully low. So if you're walking around waving your hands or you got an umbrella in your hand, there's a lot of potential for electrocution in here.
Makes sense. You got your feeder lines. They're the lines coming out of the distribution substation, or I guess they're also referred to as main lines. So the main lines are the power lines that come out of the distribution substation at the appropriate voltage for residential and commercial use.
Okay.
I don't know what that email thing is there.
Hey, Michael.
Fuse tap, a power line coming off the main line to direct some electricity in a different direction than the main lines. So a fuse tap is a junction where it's protected by a switch and a fuse in case if there's a fault.
Right. Robbie, you check this picture out. You're muted.
Go ahead.
Have you looking at this picture?
Yes.
So I've got line fuse tap. Here's my primary tap coming off here.
Yep.
Secondary off here. Look what they're calling the neutral wire.
Yeah, I looked at that. That's a cable. Time.
That's cable TV or telephone. So
Right.
the picture's labeled wrong. Not your fault, Willison. Some companies do this, and it's kind of dangerous. There is a neutral wrapped up in the secondary, and they'll use the neutral for secondary and primary in this span, and that's not a good practice right there.
Right. At all.
I think I had that same picture.
Tap line's the same thing as a fuse tap. It just there's no fuse protection, so if there's a fault, it's going to affect the main line as well.
That's true. And wow, man, what happened? A hurricane? Oh, a tree fell on the line.
Then you got your step down transformer, your distribution voltage to secondary. It's used to convert the mainline voltage into a lower voltage 240 and 120 for residential and commercial use. Your secondary lines are the power lines that have been stepped down for the 120 and 240 voltage for residential and commercial use, and still need to travel to their final destination. And
Okay.
any line that spans structure to structure but is not being fed to the meter.
Correct. Good in your explanation here. Kind of like the picture right here. This has got two types of secondary lines. One is overhead, and you'll see these lines that are going in this direction. And they're also tapping off this secondary, and they're going where?
Right, underground.
They're going underground too. So it's out of the picture. We don't know if they go to another location or if they're going to the meter or not, but that may be a secondary or service. So there's both overhead and underground secondaries.
I didn't even notice that.
Yeah, good picture.
And then your service lines are your service lines that span from the transformer or the secondary lines to the meter.
Correct.
And then your meter is the measures the amount of electricity in amps that are being consumed so you can get billed.
Correct.
Ooh.
Questions? Yeah, where'd you find that explosion?
I just looked up transformer explosions.
That's a good one.
Cool picture. All right. Good job, man. Appreciate it.
All right, thank you.
Hey, there.
Yes, sir.
Did he go? You remember what we were talking about yesterday about why you didn't close the switch in, out of the bucket? Did you just see how violent looking that transformer explosion was?
Kind of, sort of.
Yeah, that's why.
Okay.
You don't want to be near that.
Anybody volunteers?
I'll go next.
Who was that?
Whittington.
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 If you can share for me, sir, I'm on my phone.
Sure. Come on, man. There you go. All right, Mr. Whittington, you have the con.
Thanks, sir. All right, gentlemen, I got my generation to meter project. First slide's going to be a steam generator. That's where the process starts. Large amounts of electricity is not abundant in nature, so it has to be created in a generating station.
Okay. Where did you find this picture? That thing's got to be back from the 1920s.
It was actually, I just typed in generating station, and that was like the fifth one that came up, and it's pretty neat, ancient looking. So
It's actually, if you guys look at this thing, it's left, it's a right to left. This is the steam input and turbine part of it. That's the actual generator going right there. Pretty cool picture.
thank you. Coming out of the generating station, you got a step-up transformer. which gets it ready for transmission voltage, because it's a lot cheaper than trying to get it up to transmission voltage in the generating station.
Okay.
And then we've got a switch yard, which takes transmission voltage and distributes it. It doesn't step up or down voltage like a substation.
Correct.
And then we've got transmission lines, which carry high voltage from generating plants to substations. In the U.S., it generally ranges from 34.5 kV to 786 kV.
Okay, same thing I told there. You watch your A's. A's refer to transformers, just kV refers to voltage on lines.
And then we've got a substation, and even though it has many moving parts in it, its primary function is to transform the voltage from transmission to distribution voltage to be able to go out to the end user.
Correct.
It does that with a step-down transformer, which uses winding ratio to step it down primary to secondary for distribution voltage.
Correct.
And then you've got your distribution bus, which helps distribute that amperage and voltage to head back out.
Mm-hmm. I like the part does not change amps or volts. It's just bus.
Yes, sir. And you've got a oil circuit breaker in there, which helps prevent damage in the event of a fault. The oil in the circuit breaker prevents arcing when the switch is activated.
And helps cooling. Like that description right there. Yeah, that's what you'll see in transformers and the mineral oil is in there actually for a cooling process. There are some switches in transformers that you can open and close, both in pad mount and pole mount equipment. But the oil itself, when you say dielectric, what does dielectric mean?
I'm not too sure on that one, sir.
It's non-conductive. It's non-conductive. It extinguishes the arc inside that oil environment right there, so you don't have an arc flashing from here out to the side of the tank. Good picture.
Thank you. Then you've got your voltage regulators, which keeps it within 5% of the distribution voltage coming out of the substation.
Mm-hmm.
And then you got your feeder circuit, which is the lines that transfer electricity from the substation to the consumer via primary voltage.
Okay. Kind of like in your picture here, it's a little bit different from what I would typically see. So you've got a high voltage, medium voltage substation, and you're going out of that substation with your feeder line. You can have service drops off your feeder line if you have transformation, or you can have fused tap lines that go to houses, or you can have low voltage overhead. I would suspect this right here because it's not fused, that now that's a solid tap in this picture. And then you have low voltage feeders. When they say overhead and then cable, this is probably underground. Pretty different picture, but you can give a description on it.
Yeah.
Then you got your tap lines. Those are the lines coming out of the main feeder distribution power line. They can be overhead or underground.
Yep, you got overhead. When you say overhead and underground, he's got an underground line coming off of here that's tapping off. And then you guys must have found the same kind of website here. The tree fell in the line over here. So
Yeah.
the overhead tap line, yeah.
Then you've got you have solid and fused tap lines. Solid tap lines offer no protection to the circuit, where fused tap lines can prevent damage when a
Correct.
fault occurs.
When you say prevent damage, do they prevent damage to the line itself here, or the feeder, or both?
I would imagine both.
Correct.
And then you've got a step-down transformer before it goes to the home, which takes the distribution voltage and steps it down to 240, 120 to be able to go into the home.
Mm-hmm.
And you got your secondary voltage, which is the lower set of lines on the pole. They span structure to structure as the 240. but do not run to an end user.
Right. You'll notice here, and these are kind of hard to tell sometimes. You see the size of these insulators that are on the top?
Yes, sir.
So we know we've got a higher primary voltage, and the insulators down here are somewhat smaller, which can be a secondary niche condition. But I'd like to talk about this picture just a little bit. What are these?
Regulators.
Yeah, whoever said regulators is right on the spot. Because there's different fashions, and you'll see these driving around. I don't have to have all my regulators in one platform bank. I don't have to have them in a substation. I can actually separate them out and put them on 3 different poles. So those are 3 voltage regulators installed on 3 poles.
And then your service lines are lines that run out to the end user, carry 240.
Yeah,
120.
glad you got this right picture right here. 240 to house.
And then you've got your meter, which is the end of the line. It's where the device that measures the amps used in the home.
That's it. Stick me with a fork. I'm done. Good job.
Thanks, sir.
All right. What time are we holding here? 10:30. We got some time. Next.
I'll go.
Is that Melton?
Yep.
Which one do you want me to use?
Either one.
Okay. Are you awake, Matthew?
No, I'm dead.
All right. Hold on.
Yeah.
It's loading up.
All right.
All right, Mr. Matthew, here we go.
All right. Did my PowerPoint on generation to meter components. All right, next slide. Next one.
You don't want this one?
Hold on. It just showed my,
I think it's awesomely cool. I don't know where you got this picture from. Generating station, how many units are there?
2.
2 units.
Yeah.
And you'll notice that it's kind of hard to see in the picture. 1 transformer, 2 transformers, switching yard, then out on transmission.
Yep.
That's a pretty awesome picture.
All right, step-up transformer. It's a transformer in which the output is greater than an input voltage. Is called a step-up transformer. Our power companies use them to transmit electricity over long distances. The step-up transformer decreases the output current from keeping the input and output power of the system equal. The number of turns of the secondary of the transformer is greater than that of the primary. Smaller wire can be used to send electricity over long distances.
Good description.
All right. Switch yard. I didn't get no picture for this. I don't think.
Well,
I think it's in the next one though. Yeah.
okay.
There you go. A switch yard is a substation without transformers that operates only at a single voltage level. Mainly used for connections and interconnections that are important for transmission, distribution, collection, and controlling the flow of electricity.
Okay. So that's your switch yard right out there in the main part of that, correct?
Yeah.
Yep. Okay. There's your step-up transformer. This computer's gone amok on me. All right, switch yard. There you go.
Yep.
All right. Transmission.
Our transmission lines, which consist of heavy cables strung between towers that carry from where it is generated to areas where it is needed. The transmission network also allows the movement of large amounts of power over long distances. The high voltage transmission grid is the vital link or important link between power plants that generate electricity and the people who need it.
Good description.
All right, step down transformer. A step down transformer changes the entire power output from one specific voltage to another, as the transformer secondary winding that delivers the energy has less turns than the primary winding.
You're right. You guys, in looking at this transformer, do you think this is a distribution substation transformer? Be careful.
Nope.
Who said?
Looks like a transmission, maybe.
To be honest with you, he just caught a picture here of one that's in transit. Substation transformers don't come with any oil in them. They don't come with any bushings on them. You got to build them at the station. If you put all that stuff on them, for one thing, it makes this thing much, much lighter as far as the installation of it. A typical Santee Cooper substation transformer is going to run you right around 120 to 130 tons. So if you're able to limit the amount of weight that you have on the transformer to be able to set it, this is one that just hasn't been built yet.
All right, breaker. A breaker is an electrical switch that protects an electrical circuit from damage. It protects systems from overloads, transformer faults, and falls to the ground, which results it to stop electrical flow.
Okay. I think I went one too far. Hold on. There you go.
Feeder. So,
sorry. Voltage regulator.
And don't pass this that. Yeah, don't pass that in the picture. It said voltage regulator is an integrated circuit that provides a constant fixed output voltage regardless of change in the load or input voltage.
Okay, is this a voltage regulator for an electronic circuit, or is this a voltage regulator for a substation?
That's the first one you said.
Yeah, electronic circuit.
It's not for a substation.
Okay.
Yeah. All right, feeder. A branch in a network which connects smaller or more nodes with a route or branch carrying heavier traffic, aka mainline.
Okay.
Yeah. All right, fuse tap. Fuse taps are used to run power off the feeder line onto the other lines and protect the feeder lines from short circuits or overloads.
Okay. Close on the picture right here. This is what they call the 3-bear switch. Kind of funny. You actually have a primary voltage coming in, going down to a voltage regulator, coming out of the voltage regulator, going back up, and then back out on the line. So this is really the same voltage going through a voltage regulator.
Mm-hmm.
Solid tap.
All right. Yep, this is the one I had a picture for. Solid tap used to run power from one feeder line another and connected to the primary line without a fuse and does not protect the lines from fault.
Good description. Are you still with us, Mr. Mountain?
Yeah, I'm here. It was lagging. I don't know where it's. Hold up. All right. Secondary lines come from transformers and run NRM from structure of.
Okay. Sounds like he's R2D2ing. Still
Something
with us?
wrong. Hold on. I don't know, something wrong with my Zoom.
It's your McDonald's internet.
Yeah,
Yeah.
you're right. Service line is the line that comes from the secondary and is used for a resident or any, any building that needs it.
Right, correct. That's a good picture of it.
All right, a meter. All right, it is a device that measures the amount of electricity consumed in a resident.
Okay. Good job.
I appreciate it.
What's the purpose of running power off the line and then feeding it back onto the same line?
In the picture that you had previously?
Yes, sir.
And this one right here, if I was to go under here and show the rest of what's going on, you're going to have 3 voltage regulators down here at the bottom. And what they're doing here is they're coming, and I don't know directivity on this. They're coming in from this direction. They're going down this switch here into the voltage regulator, stepping up the voltage, coming back out into this switch, and then going back out on the line. You'll notice right here, and this is what they call a flying dead end.
Oh, so electricity can't flow anymore.
Electricity is not going through this point. They call that a flying dead end. Now, the switch is made in such, and I wish I had a close-up of the switch, is you're able to bypass this without cutting power off. So say if I needed to work on the voltage regulator, you can do an assortment of things with this switch right here to be able to just open one and open the other, still maintain power through here, and work on the regulator without disrupting customers.
Okay, so you could have either a voltage regulator or like a step-up transformer at the bottom.
Yeah, you can pretty much have anything that you wanted to. Yeah, down here at the bottom. But yeah, this is the main part you need to look at right here. No voltage.
Right, I figured electricity was still flowing. That's why I didn't understand.
No voltage is traveling between here. It's going down, whatever it is down here, back up and out.
Makes sense.
Okay.
Thank you.
You're welcome. Why do I have it up 3 times? Whoa. I want you to see my email. Next.
I can go next.
That was Hopkins.
Yep.
He's got a true PowerPoint.
Oh man, he's got a PowerPoint. Big expectations for you, Jesse.
Yeah, here it comes.
Oh boy.
Got to hold up to the Carpesi scan. Standard.
It's Taco Tuesday.
Is it really?
It is.
All right.
I don't want to talk about it.
All right, here we go, Jesse. All yours.
All right, this is my generation to meter presentation. Obviously by me, Jesse Hopkins. Here we have the generating station where you'll use mechanical energy such as coal, nuclear, hydro, wind, solar, and a few others. They'll use that to turn the mechanical energy by turning a turbine with the magnetic field to create the voltage. With our step-up transformer, after it comes out of the generator, you'll step up from a lower voltage to a transmission voltage. That way it's more efficient. You can use smaller wire. Don't have to have giant wire that you can't even get up in the air. It's a lot more cost effective.
Correct.
Do it that way. Here
Sorry.
we have our, oh, you're good. Got the transmission lines.
I double clicked there. Sorry about that. Go back to switch yard.
Yep, the switch yard. You have your transmission lines coming out. The switch yard is used to switch the electricity to different transmission lines to where it's needed.
Okay.
And go in multiple directions. And then the transmission lines will carry your power from your generating station coming out of the switch yard all the way down to a substation, so it can turn into distribution coming out of there. And in our substation, basically you're going to use a step down transformer to take the higher voltage off of the transmission lines, and the output should be a lower voltage that you can easily send through neighborhoods and to businesses. And with that, you're using your step down transformer. You have your, on the picture there, you have your higher voltage coming in from the left, your lower voltage coming out the right as you step down, to your typical distribution voltage there.
Okay, you want to rephrase that again as far as your left to right?
Your higher voltage should be on your left, right? With the bigger bushing. Are we going right to left with the higher voltage?
What size bushing do I have here? Left?
Yeah, you got your smaller bushing on your left and your bigger bushing on your right.
Which is distribution,
Should be your smaller bushing
right? And transmission?
on the left. Yep, on your bigger bushing there on the right.
Correct, good.
Yep. Said that backwards. With your bus bars, it's a bigger conductor, so you can send more amperage, switching around in a substation to go out on the different feeders.
Okay,
And then your breaker is a device used to stop the electrical flow if you have any type of faults or overloads or anything down the line that can cause damage to the system.
all right.
And it's automatically operated.
Right. This is a breaker, transmission or distribution?
That'd be a transmission.
Correct, gas operated.
Gotcha. And your voltage regulators, I guess these are the older ones, like you were saying, pad mounted on the ground. But that's to give you a constant voltage, keep it within the 5% of what it's supposed to be to adjust for the load.
Okay.
They're the longer distribution lines, it keeps your voltage more constant.
Right. These conform okay. The ones that we saw before, the actual regulator tank was on the concrete pad. These are under racks. See how they're extended up in the air? So this is more modern.
Gotcha. And then your feeder circuit is what you have coming out of your distribution substation. Primary voltages travel on these lines so you can go out, send them to businesses, customers, homeowners, go all the way to your distribution transformers. And then you have your fuse. Go ahead.
I said okay.
Okay. Your fuse tap line is a tap line coming off of your feeder line to another feeder line. You have the fuse in there to protect from faults, overloads, things of that nature, not affect too many people on the feeder line,
Okay.
the larger feeder line.
Watch how you state that. As soon as you tap off a feeder line, it's called a tap line. So
Okay, to your tap line.
Feeder to another feeder. Okay. As soon as this happens, either in the solid or fused, as soon as I come off the feeder line to another line that's either solid or fused, it is now called a tap line.
Gotcha.
It's just terminology.
And then here we have the solid tap line where you're hardwired into your tap line from your feeder line, which that offers no protection. Any sort of problem down line can affect the whole system.
Right, good description.
You have your distribution transformers. That's where you're taking your primary voltage, converting over to a secondary voltage, which is lower for homes and businesses. It's typical 12240 to a home, a little higher for industrial businesses, things like that.
Correct. We'll discuss that later.
Your secondary line is once you come out of your transformer, traveling from span to span, to travel to customers with the lower voltage from pole to pole is your secondary line.
Okay.
And then your service line is once you come off the secondary line going directly to a customer to their meter base.
Okay.
And then here we have the meter. The amperage turns the little money wheel on there, so
Money.
get a reading of how much power is being used by the customer.
Excellent. Fine job.
Thank you.
Okay, any questions on that one, anybody? Robbie, I got your text.
Okay.
All right.
I'll go.
Who said it? I'll go.
John.
Okay. It's in PDF, so I'm gonna have to scroll pages as we go. Okay.
Yeah, that's cool. Do you want me to switch the screen and do it? Doesn't matter to me.
I'll scroll for you.
All right. All right. Generation to meter presentation. Starts at the generating station. Uses raw resources, fuel to transform water to steam by heating process. Examples are coal, natural gas, uranium, wind, and solar. From there, the steam is sent to a turbine where the pressure causes the blades on the turbine to spin at a high rate of speed. After this shaft is connected between the turbine and a generator. Inside the generator is a magnetic field which produces voltage or electricity, approximately 15,000 volts from the source I got it from.
Okay.
Picture kind of shows a diagram of a generation station. It's kind of small though.
I got the technology now. Okay.
Step up transformer is a well, in this case, it's a transmission transformer that increases the voltage from the generating station. High voltage power produced by the generator enters the transmission substation, the power plant. Inside the substation, large transformers convert the generator's voltage up to extremely high voltages. In that case, 115,000 to 500,000 volt range in order for it to travel more efficiently over the transmission lines.
Right. You'll see this in the more modern generating stations, and sometimes you see it in substations. This wall that they put in between is actually an explosive barricade. So if you have a catastrophic failure of the transformer right here, either one, the damages that go on in here are funneled up and won't damage the next transformer over. These things, these transformers, gentlemen, are grossly expensive.
The switch yard is found near or adjacent to the generating station. Directs powers to different transmission lines. Switching is the connecting or disconnecting of transmission lines or other components to and from the system. Planned switching can be to de-energize for maintenance. Unplanned switching for faults to prevent further damage. Examples: tower blown down by high wind, a line hit by lightning. Does not step up or step down voltage, does not have a transformer. It operates at a single voltage level.
Good description. Sorry.
Transmission, once stepped up to the appropriate voltage, the switchyard tells it where to go. And the switchyard tells it where to go. The power is then placed on the transmission system, which consists of lines and poles, very high voltage. 34.5 kV to 786 kV in the US, travels very far distances to the distribution substation. Distribution substation, main purpose is to step down high transmission voltage to lower distribution voltage, isolates faults, voltage regulation, and feeds distribution lines.
That's a good outline of the total what happens in a substation. Good one.
Don't have a dedicated slide for the step down transformer. It is in that picture from before, but the step down transformer just takes the transmission voltage and changes it to a distribution voltage.
Right. And some companies do it in this fashion. We actually have a 34.5 kV incoming voltage. We'll have a breaker right here. Then we'll have it going out to the transformer. This transformer is going to take that 34.5 kV and convert it down to, does he have a voltage? He does. 7.2 kV. So here's your substation transformer. So there's a breaker on both sides, one to protect the transformer and one to protect the feeder circuit.
The substation bus bar is a solid metallic bar used to distribute high amperage through an internal network throughout the substation. Copper or aluminum are
Correct.
used. Circuit breaker opens and closes a circuit, can be operated manually to perform maintenance, operates automatically to protect the system from faults, overloads, and faults to ground.
Good picture.
Voltage regulator maintains and monitors voltage, step up or step down voltage to maintain the plus or minus 5%. Poorly regulated voltage results in unacceptable equipment performance. Some but not all problems from poor voltage regulation, damage to electronics, inefficient operation of motors, or dim lights.
Good.
Feeder line takes primary distribution voltage from the distribution substation to the customer, aka the main line.
Okay, so looking at your picture here, left and right lines, which one's your feeder circuit? Which one's your transmission circuit?
Left is feeder, right is transmission.
Correct.
Tap lines are connected to a feeder line with, or in this case, fuse taps are tap lines that are connected to a feeder line with a fuse in between the tap and feeder. Fuse cutouts are fuse switches that sectionalize a segment of tap line from the distribution line or protect distribution line from short circuits or overloads.
Good.
Not a great picture, but the solid taps are just tap lines that don't have the line fuses or cutouts in them.
Correct.
Step down transformer for distribution transformers or transformer on the pole that steps down the voltage even more to 120, 240 volts so it can be delivered to a house or other building.
Correct.
I'll be honest, these next two are kind of inaccurate. I had a little bit of trouble with them, but the second.
Hold on one second. I'm going to go back to this other slide. Okay. So secondary lines per this picture is which one? So I'm going from structure to structure with this line. Is this your secondary line?
Yes.
Correct. Okay. Now I'm coming directly off the transformers and going to a metered building. Is this your service line?
Yes.
So you answered it all here. You answered both those slides in just this one picture. It's got both of them in it. Let me see your description.
I was a little bit mixed up with, I got lucky with feeder, but all three of those kind of wasn't really, I wasn't really sure.
No, okay. And
But like everyone else's presentation, I got it.
right, there's either one or the other that's going on right here. So your secondary line description, the line from the transformer to the leave house out, structure to structure. That's secondary line. And we'll go down to your service line, the line that runs from structure to the meter. That is correct.
Okay.
So, and you got the picture absolutely correct. Comes from the structure over to the meter. Is that thunder?
Yeah, I had thunder.
Yeah. All right. And your meter.
Meter is an instrument that measures amps consumed by consumer.
Right. This is kind of a weird one that's going on here, guys. They're taking an old meter and they've actually installed an electronic meter here just for testing purposes. That's why you have 2 meters on that meter base. Okay, good deal. Who's left?
Yeah, I'll go.
Who was Elijah? Elijah. It doesn't matter which one I use here?
What does that say? Generation meter? That's probably
generation meter, and this. Oh, that's right.
Yeah.
Presentation this morning. All right, open. And start slideshow.
okay. Generation to meter, how electricity is produced and distributed to residencies. First, we start with the electrical generator, which electrical generator uses voltage, current, and movement to create electricity.
Correct.
And then it goes to a step-up transformer, which steps up the voltage. A step-up transformer is a voltage that increases a transformer that increases the voltage from primary to secondary, meaning that there is more secondary winding than primary. It's called a step-up transformer because it increases the voltage produced by the generator.
Okay. Okay. Make sure you include generator, not an alternator.
The switch yard, it goes from there to a switch yard. A switch yard is interconnection between the generator and transmission, and the same voltage is maintained through the switch yard. The main application of a switch yard is to deliver the generated power from the power plant at a desired voltage to the nearest grid or transmission line.
Good description.
And then we go to the transmission lines. Electric power transmission is the bulk movement of electrical energy from a generating site, such as a power plant, to an electrical substation. And
Where
then
in the world did you find this picture?
I looked up transmission lines.
Wow. They actually set a pole beside a transmission line so they can work off the pole on the transmission circuit. That's kind of weird.
I thought it looked pretty cool. It's got linemen in there.
Pretty cool.
But now we're at the substation, which is an electrical substation is a part of an electric energy conversion and distribution system. Substations are designed for all voltages. They convert voltage from high to low and in reverse. The electrical network defines the purpose, power, and voltage of the substations.
Okay.
And then we go to a step-down transformer, which is like the step-out transformer, but in reverse. A step-down transformer is designed to reduce the voltage from the primary winding to secondary winding. Step-down transformers convert high voltage and low current alternating source to a low voltage and high current alternating supply.
Good description.
Then we go to the substation bus. An electrical bus bar is defined as a conductor or a group of conductors used for collecting electric power from the incoming feeders and distributes them to the outgoing feeders.
Mm-hmm.
In other words, it is a type of electrical junction in which all the incoming outgoing electrical current meets. Thus, the electrical bus bar collects the electric power at one location.
I like this picture right here, the way you got it. And actually, in real life, I mean, this looks huge, and it is huge in real life. But essentially, what you could do, you see your incoming transmission lines coming in on the left. In the background, with all your bus work and all the switching capabilities, I'm able to take one line in that feeds in and feed all the other lines out, or take two sets of lines in and feed. I mean, the switching capabilities as far as bus work is concerned and what you see in this are just limitless. Good picture.
And here we have a circuit breaker. The circuit breaker is an automatically operated electrical switch designed to protect an electrical current from damage caused by overload or short circuit.
This is a more modern circuit breaker right here. It's gas operated.
Then we move to the voltage regulator. The voltage regulator, the purpose of a voltage regulator is to keep the voltage in a circuit relatively close to a desired value. Voltage regulators are one of the most common electronic components since a power supply frequently produces raw current that would otherwise damage one of the components in the circuit. And what's cool, I was driving through Conway the other day actually, and I actually saw they have a voltage regulator along the power lines there.
Mm-hmm.
Looks just like this, except it's on a wooden platform.
Okay.
But yeah, that's just some cool I saw. Then we move to a feeder line, which I believe behind the transformer. You see it right there?
You want this one right here?
The one, no, lower.
This one right here?
Lower.
This one right here?
I believe so, right?
Okay. So
It's coming off.
We'll talk about this for just a moment. Your voltages and your priorities are going to start from top to bottom. So this is my feeder circuit on top.
Oh, okay.
Okay. my tap on the bottom, which is actually, is this a fused or a solid tap?
That looks solid. There's no
Solid
fuse
tap.
there, right?
Then I've got a transformer here. And then I've got actual secondary coming off the transformer. So as the order that you went in your slides, it actually goes from top to bottom.
Okay.
Feeder,
Okay.
tap, transformation. There's no secondary here, but there's service. Okay.
All right. A feeder line is part of an electrical distribution network, an electrical wiring circuit in a building which carries power from a transformer or switchgear to a distribution panel.
The description's a little bit off, but it's close. That's for
Right.
an electrician.
Okay. Is it? It would have been from what is it? What I'm trying to say, from service to service or between the lines, right?
Your feeder line is the main line. Like we said before, a feeder line is the main line. And off that feeder,
Right.
line, feeder circuit, you're able to have solid or fused taps that go out. Yeah, that go out. We'll talk more about radial and loop systems later on, but that's all that you need in that description.
Okay.
Okay.
And then here we have a fuse tap. It's the line that goes off of the feeder, and you can see it coming down onto the fuse right there. Fuse taps are used to run power off of the feeder lines onto other lines
Correct.
through a feeder or other application. And then the next slide is a solid tap, and you see it comes off of the feeder line, and there's no fuse or switch off there, so it's just solid.
Correct.
Solid tap connects from a feeder line to a line that taps off without a fuse or a switch.
Correct.
And here's a transformer. Here this is going to work as a step down, but on a pole you just see this transformer. A transformer is a device that is used to either raise or lower voltages and currents in an electrical circuit. So what this would do is transform the voltage coming into and distribute it to a residency at a lower voltage.
Correct. So I have an inbound primary voltage at the top, and outbound I have a residential voltage like 120, 240, correct?
Right.
Okay.
And then we have secondary lines. Secondary lines distribute the low voltage side of the distribution transformers. They're called secondary distribution lines or secondaries.
Mm-hmm. I suspect you're going to use the same picture here. Oh, that's okay.
And here is the service drop. The service drop is an overhead electrical line running from a pole to a home or building. It is the point where electrical utilities provide power to their customers.
Okay, so you've got, both pictures are correct. So you're showing a service line coming into a house, and you also had it in this picture also, coming directly off the transformer, service drop to house, or from the structure, service drop to house.
And then it ends at the electrical meter. An electrical meter is used to measure the amount of energy consumption of a home or building. The more amperage that is consumed in a home, the faster the meter will turn.
Correct. Well done.
Sweet.
Sweet. All right. So I am holding Trevor. Who's Trevor? My resume. That's another Trevor. Noah Oliver, you ready? Come in, Berlin. He's not even in here in the group. Gentlemen, we are finished. It's 11:07. Professor V already left for the field.
There's a lot of lightning, isn't there?
That's what we're getting ready to look at. Well, it seems isolated. Let me look at one more. light19maps.org. And let's go to the Americas. We want to go back, see what's happening in real time. I want to go forward.
It's no wonder your computer crashed, Chief. You got like 12 slides open.
Sorry about that, killer. Yeah. And this thing, what are we running here? We're running about 2-second delay. You can see the strikes right there. How far is everybody away?
I'm 40 minutes away.
40 minutes.
I'm about 15, maybe 20.
I'm like 10 to 15.
I'm all the way in Loris.
Oh. Yeah, it looks like right there, he had a strike right over the field.
I heard one really close to my house a minute ago.
Let me call him real quick while y'all are here.
Rain, rain, go away.
All right, so we're going to call it this afternoon. No field this afternoon.
Man,
What's the matter, Levon? You want to get struck by lightning?
no.
Be all right. Just don't touch the wires, right?
Just don't touch anything, including me. All right, so you guys have a good afternoon. We'll prepare something for tomorrow morning. Real good on the presentations, gentlemen, and that is a grade, so I appreciate the hard work that went into them. And I'll text something out this afternoon as far as prepping up for tomorrow. We will have a morning D2L assignment in there, and then we're going to be out in the field tomorrow afternoon, weather permitting, okay?
We got D2L tomorrow or today? You said
Tomorrow.
okay.
Today was just this.
All right, cool.
Okay.
Sounds good.
All right, gentlemen, have a good day. Be safe.
Thank
All right,
you.
we'll see you later.
All right, man.